This is section 2 of paper 1 of the 2015 KCSE Maths paper. Question 20 says, in the figure below, AC is equal to 12 centimeters, AD is equal to 15 centimeters, and B is a point on AC. Angle BAD is equal to angle ADB, which is equal to 30 degrees. So the first line that we're told about is line AC, which is this line here, and we're told that it measures 12 centimeters. We're then told that line AD, which is this line here, is 15 centimeters. That's also marked on. And we're told that B is a point on AC. So if this is the line AC, this here is B. And we're told that BAD, the angle BAD, so that's the angle that goes like this, so this one here is 30 degrees, and ADB is also 30 degrees, so this angle here is also 30 degrees. And so if we know that both BAD and ADB are 30 degrees, then the triangle ABD, so this triangle here, must be an isosceles triangle because it has two angles which are the same, and therefore there must also be two sides that are of equal length. So question A, part A, asks us to calculate, correct to one decimal place, the length of CD. And that line CD is this line here. So how should we go about calculating CD? So since we're given some angles and some length, it would be right to assume that we should use trigonometry to answer this question. So we have formulae for two rules. The first one is the law of sines, which is A being a length, over sine A is equal to B over sine B, which is equal to C over sine C. So the lengths and the angles, the length A, if say A is 12, the corresponding angle sine A, so the corresponding angle A would refer to the angle that is directly opposite that side of the triangle. So it would be this whole angle, the 30 degrees plus this bit that we don't know, let's call that X. And the same for B. If we're going to designate B to be 15, then B over sine B, the capital B, would refer to this angle here. So would this be an appropriate formula to use to solve this question? It doesn't seem that it would be, because if we want to find out CD, we could use 30, so 30 would be the opposite angle, but we don't have any length angle pairs for B sine B or A sine B, say if C is going to be our CD. So we can't use the law of sines. How about the law of cosines? So the law of cosines is A squared is equal to B squared plus C squared minus 2BC cos A. So if A is CD, then we do have a directly opposite angle A, that is 30 degrees. We do have lengths B and C, those are 12 and 15 degrees. So it seems that the law of cosines is the correct formula to use to solve this question. Before I begin to use a formula to solve any kind of question like this, I always write down what each of the values that I'm going to substitute into this formula are. So A in this case is CD, that's an unknown. B could either be 15 or 12. We need to make sure that we're consistent. If we stick to using B is equal to 12, we don't switch around. So, but it doesn't really matter that much in a formula like this, but in others it might get a bit complicated. So let's say B is equal to 12, so it's this length here, that's our B. C is 15, this length here. And our angle A is 30 degrees. It's the angle that's opposite this side here, CD. So we're going to write CD squared is equal to 12 squared plus 15 squared minus 2 times by 15 times by 12 multiplied by, so that 15 here is the C, the 12 here is the B, multiplied by cos 30. And since this is a calculator paper, you can put this into your calculator and see what you get for CD squared. So 12 squared is equal to 144, plus 15 squared, which is 225, is 369. And then we're going to subtract 2 times by 15 times by 12. That is 360. And then we're going to multiply it by cos 30. Cos 30 is the same as the square root of 3 divided by 2, so multiplied by root 3 over 2. So that is what CD squared is equal to. And then what we need to do is we need to square root both sides. So what we get is CD is equal to the square root of 57.23, which to one decimal place is 7.6 centimeters. So CD is 7.6 centimeters.